So do you see my screen?
Yes, we do.
Yeah, same. So the name of article is Mitigating Input Prompt Attack Vulnerabilities in System with a Language Model Interface. All of us know that IE solution and LLMs are widely spreadly used in different applications for now, and the tempo of their implementation in different systems grows exponentially, and that for sure brings new risks. So the purpose of article is to demonstrate up-to-date types of prompt injection attacks that actually happens and are a high risk for language model interface, to make an overview of existing cybersecurity issues that appear using LLMs, and based on proposed in this article multi-level cybersecurity frameworks, some possible way to find one or another solution to solve them and limitate risk that you are exposed using LMI. Also, the main focus of article is to demonstrate suggested prompt analysis and attack detector to protect your system from injection and increase ratio of successfully limited different type of prompt injection attacks. Actually, what are the risks using LLM in your system as an interface? First of all is GPT, for example, from OpenAI provider, the most known LLM. We will mostly demonstrate results based on their open models. The first risk is information as a weapon. Because of its highly available for any type of users, different people could use it to boost their knowledge and time to perform different type of cyber attacks, to execute or even create from scratch different type of viruses, ransomware, and so on. Also, the second one is data leakage, which is actually available even to execute on different LLMs because of their knowledge base, which is not protected perfectly. And it contains for sure some sensitive business data. Some users including prompt injection attacks, could reach that data and even discover some different secured case for different software. The most known case is exposure for Microsoft operational system case that were discovered from ChatGPT because of such type of attacks. The next way to use ChatGPT to boost your hacker skills is fraud and impersonation. It was a time-consumptive way to get information from people and write mails and so on. But now it's boosted a lot using GPT. You can use LLMs that could reproduce your voice, collecting and training it on the data available for public person. You can impersonate them using fake face and other technologies. And such way, for example, was fooled a lot of people because of impersonating Elon Musk and asking to donate to some bank accounts, and it was fake for sure. Another separate type of attacks is business email compromise, or BEC. It's a type of social engineering attack that actually frauded using emails, and it mostly automated now in a better way using GPT. And this information, which is not possibly critical from first point of view, but LLM are available for such illusions, exposing fake information or disinformation for different questions. And there were some scandals when different specialists using LLMs to prepare some material for real practical cases, and based on some fake facts, try to, for example, protect different people in court or make some conclusions based on fake facts. So it's also very risky and important to filter such information and fix as much as possible such bugs exactly in LLMs. So to make possible to easy demonstrate how actually in different ways we could mitigate one or another type of risk, there is proposed overview of typical system with LLM. And we can here a typical approach, some monitoring system outside of all this our system with LLM. We use LLM as an interface. There is some API REST with internal models for a different security purpose. We accept user request, pass it through some filter layer with pre-processing and post-processing filters. We pass it to some model to process and answer, and model could use some API from third party or own implemented solution to execute some additional logic. So LLM mostly currently is used like the manager or mediator, or from user point of view, it's very smart chatbot, which actually could handle any type of request, reach any information, under the hood execute some calculation and demonstrate some intuitive, smart, interactive result. And outside of language model, for sure, we have some knowledge base where we definitely have some sensitive personal data that shouldn't be exposed directly outside, but could be used for some purpose for calculation, evaluation, and so etc. So we have, because of such structure, several layers. So first layer is the top layer model integrity. For that purpose, we could use generally available protocols and frameworks like Open Authenticate or OWASP tools. We also, after that, proceeding deeper in our system, we comes to filter layer. Actually, there are different approaches, mostly based on vocabulary solution with fuzzy search and etc. But they are not so perfect. And actually, we will concentrate in scope of this article on that layer. There is also model protection, where we could use such available solution as Stride and Octave. And about data security, we have two layers. First of all is the knowledge base, considering to protect architecture and our achievements to learn our model. So here we are going to use a wide range of different protocols of security accumulated in standards like ISO 27000. And of course, if we are talking about personal data, we should align to generally available frameworks. And considering Ukraine is moving forward to European Union, we could concentrate, for example, in scope of our area to GDRP. And there are also some entirely standardization for using actually any system. In general, you can orient on ISO or IEC 27001. So what type of attacks actually we have using prompt injection approach? We are risky to have such case as model memorization probing. It's a type of attack when a user try to misuse our LLM as an interface and reach for some sensitive information that model have memorized during training. And in case we continue to train it, it will user will try to put like two type of attacks in this area. One to reach some personal data or proprietary code to understand how he could hijack, continue that process, and another type to put misinformation with aim to spam it with it and force our model to learn that fake information and memorize it in our knowledge base. Another type of prompt injection attack is architecture and configuration probing. So actually what happens in scope of this attack, user tried to attempt and understand how our system consists inside, what model contain what information, what prompt were used in case, for example, we are using custom GPT model, and what is stored in main knowledge base, what is stored in some custom vectors, additional data, possibly some files that are stored in our storage, and so on. Bias probing, it's mostly related to exploit some responses that could be gender, race, or religion sensitive, and then to highlight that our system is not tolerant to some type of information or show some very confusing facts and so on. It's a very famous situation and scandal with Gemini release from Google when they stuck and even revert and close the release for some period. Unauthorized access probing, this type of attacks is actually when you have different type of users and you expect that some user are accessing to the same LLM to execute one type of action with higher permission, and another user, for example, reach in a common way just to execute several available actions, but because of the same LLM and not limiting by default any prompts, user could execute some actions as a high priority user without even availability for that according to some session and common standard existing flows. And prompt chain attacks is the most tricky way to reach any type of previous attack purpose, but you are using the sequence of prompts because from the first try, LLM is available to handle such attack in some cases. But if you are moving forward from some abstract topic directly to narrowing to your aim, and bypassing obvious understandings that it looks like attack. For example, you try firstly to discuss general topic about cybersecurity, and moving forward, at some point you already ask LLM to demonstrate you examples how you can, for example, write virus, or for example, to demonstrate you some malicious prompts for some type of attack. And at that point, LLM probably, in most cases, could skip any risk and demonstrate any type information that you could use for further attacks. So to now to understand how it all applied in a system with real application, here is a system used in previous research. It's devoted to warehouse design calculations. So here we can describe it shortly. It's an existing system where you can execute different actions like place an order, create an application, verify current order list, and so on. All related to logistic domain, and we put all this functionality not directly like a button in interface, but using some core LLM that is educated to execute different type of actions, reach different information, and formulate user oriented response, not like digits, but full explanation, put some analyze on the digits and put some suggestions. So it's very good solution. But it's risky because we have no cybersecurity level enough for exactly filtering. Because authentication and authorization we already have from Box in previously developed as a standard approach. We have MongoDB for that part of layer. We have requests that are handled using event-driven architecture. We have some caching processor to collect and populate some information, and all we need for some monitoring purpose of how our system works, success of our users, some statistic per user per system at all. And we have no filter layer described before, and no ready app solutions, excluding some fuzzy search, vocabulary, and general approach that are not so perfect. So how it works? We are adding here additional subsystem highlighted with green. We have a filtering request processor and filtering response processor. In case of input was somehow passed by, but in response we could detect some sensitive information that is not able to expose, we could cut down attack in both direction and in two steps. Also, we have attack validators that will be paid attention later. We have prompt analyzing. That is some pre-processing before passing it to attack validator LLM. And we have Elasticsearch monitoring for two purposes. One is to collect some statistic per user and use previous prompt to avoid and eliminate prompt chain attack. And another purpose to track our subsystem. So actually, what logic is used there? We have some previous prompts that could be used for prompt chain analyzing attacks. So we need to collect some the latest number of prompts, some vector of them. And for that purpose, we used, for example, for testing this number of 5, the latest prompts. And in most cases, it was considering testing results enough. Also, we have the union between this current prompt and previous prompt, combining as some context window for our full processing and detecting type of attacks. And we have some input prompt processor, which consists from different steps. So the first step is like from inside braces to the outside. Moving, first step is cleanup function, where we remove special symbols from input prompts, resulting in a prompt with some available characters and spaces and so on, splitting them into token as the next step. So we execute tokenization function, collecting already the number of tokens for further processing, then going function lemmatization, which maps our token to some dictionary, and reduction of prompt at all. Then we're producing lemma, and after that we execute some stemming function, which we truncate and use on the left tokens for our storage purpose, and executing actually this stemming using NLT key Python library. So as a result, we could use different approaches, and for test purpose, we testing different scenarios for different type of attacks, for different setups to demonstrate benefits of using LLM as additional tool to limitate prompt injection attack. And we use the standard classic way to do it. After full processing described before, we could use fuzzy search because it's oriented already for pre-processed data and tokens. So we have generating 500 of prompts and additional 300 for some safe usage prompts, combining with prompt related to different type of attacks. 5 of them, that's why 500. And we execute that performance comparison of 3 attack validators that will be demonstrated at the end. So what are setups? We have 5 setups. Two of them are containing default GPT LLM model, publicly available of versions 3 and 4. We have fuzzy search attack validator based on vocabulary comparison. And we have GPT 3 and 4 LLMs models used as attack validator in our additional subsystem. What we are using during test scenarios, we have different type of runs described for different type of attacks, and it is executed for each type of setup described before. What is specific, it's additional up to 457 user inputs. Because of prompt chain attack, it contains a higher amount of prompts because there are actually 100 mini sets of prompts to execute this chain simulation attack. For each number of execution, we accumulate information described before. I wouldn't concentrate on true positive, true negative, and other statistics widely used across. So here is additional information. We use F1 score to evaluate different solutions. And here is results. So here you can see 5 tables, each table per each type of attack. In each table, you can see 5 rows. Each row is devoted to some default setup. It's standard or default GPT model availability to track and cut down some type of attacks that it looks like misuse for it. There is fuzzy search validator. And there are 2 setups of attack validator based on one or another GPT version. So as we can see here, for sure, fuzzy search demonstrate for all type of attacks some benefit because of higher probability to detect true positive, like true attacks. But in most cases, its precision is lower even comparing to no security solution with just using core GPT version of 4, because it's not tolerate to even valid, like no attack prompts, but because of vocabulary approach, it tracks it as a potential attack because of using some familiar words that could be used also in attack prompt. So it's very confusable, and from user point of view, in most cases, sorry, I heard echo. Yeah, in most cases, it's not acceptable on practice. So especially it's obvious on prompt chain attack, the most complicated case, where we can orient it according to F1 score, for example, only to GPT-4 version, because all our solutions are lower than 50% according to this score. And we could also obviously see that for some type of attacks, even default GPTs are not so bad. For example, for BIOS probing, they are very good oriented in that case, and it demonstrates nearly the same results that we achieve using our additional attack validator layer. But in other type of attacks, especially considering prompt chain attack, or even model memorization probing attack and architecture and configuration probing attack, it's obvious that it's not acceptable to use in production the LLM as a core for exposed directly as an interface to user without any additional security verification. So in
Excuse
such
me,
case,
Alexander, you have spent more than 20 minutes. Summarize, please.
sorry. Yeah, let's fastly move forward. So here is performance. GPT-4 for sure is slower, but on practice, it's not so important for user to put prompt and wait not like 100 milliseconds, but up to 1 second in most cases, considering average value. So both solution, both LLMs are fully acceptable for that. And as conclusion, as you can see, it's very important to pay attention to cybersecurity questions when you are developing and designing your system considering to use LLM as an interface, because without any filter, you will get into troubles. And from our test results, there is obvious that you can find some balance between using further search for the most cases, but in case you are not sure, so probability according to token detection is lower than, for example, some threshold defined by you, you can use and must use in most cases some additional tool and propose solution with attack validators based on GPT models, which demonstrate in all type of attacks results from 76 up to 97 of detection, prominent detection attacks is a good way. So thanks for your attention. Sorry to get a bit more time.
Okay, thank you. Dear colleagues, one questions maybe you have? No questions?